The purpose of this video is to explain what is absorption. We will learn its definition, principles, and mechanism of absorption. This video will also highlight how absorption is applied in natural and industrial area, and at the same time demonstrate absorption theory linked to our real-life application. So this video will simplify the complex concept and emphasize the absorption's importance across various fields.
For my part, I'm going to cover the fundamental of absorption, which we are going to cover for four components, which is the first one is the definition, where absorption is a critical process where one substance, which is the adsorbate, is taken up by the other one, which is the adsorbent. And it is also a process of separation of solid from a gas phase by contacting gas with the liquid phase. And absorption is a process whereby all the molecules, atoms, and ion enter the bulk phase of a material. So for the next slide, I'm going to be talking about the second component, which is the key principles. Based on the slide, we have 5, and the first one is the mass transfer. For the we know that absorption is a fundamentally mass transfer operation, and the efficiency of transfer is influenced by the concentration gradient, temperature, and pressure conditions. And for the second one, we have solubility, where higher solubility generally leads to more effective absorption, as it allows greater quantities to dissolve in the liquid. And the third one, we have adsorbent selection, where ideal adsorbent will give you high selectivity, low volatility, stable under operational condition, non-toxic, and cost effective. And the example of ideal absorbent is such as water and organic solvent. And the fourth one, we have equipment design, where basically adsorbent usually occurs in a specialized equipment such as pack column and spray towers. And basically the purpose of doing the process of absorption in such specialized equipment because we want to obtain optimal contact between the gas and liquid phase. And then the last one, we have equilibrium, where absorption provides equilibrium relationship, which we can use it to dictate how much of a gas can be absorbed at a given concentration and
So for the next
slide, I'm going to talk about the process diagram, which we have two. The first one is the single stage equilibrium contact, and the second one is the counter-current multiple contact stages, where looking at the single stage contact diagram, we know that V2 and L0 is the inlet stream, where V1 and L1 is the outlet stream. And we know that at single stage in the absorber, with looking at the diagram, the rectangle one is the absorber, is where the gas phase dissolves into the liquid phase due to a concentration gradient. While for the second diagram, for the counter-current multiple stages, we know that V1 and L0 is the operating point 1, and V and plus 1 and L1 is the operating point 2. And we know that for the multi-stages diagram, we know that multi-stage, which means have many stages, and at each stage it allows for interaction between gas and liquid. And for the last slide, I'm going to talk about the factors affecting absorption, which is based on the slide. We have 4, and the first one is the concentration of the adsorbate, where higher concentration of the adsorbate in the gas phase will lead to an increase of absorption rates. And the second one is temperature. For the temperature, it varies. It's either for physical absorption or chemical absorption. And as for the physical one, higher temperatures can decrease absorption rate due to increased kinetic energy of molecules, while for the chemical absorption, we favor at lower temperature if it is exothermic. And the third one, pressure. So basically we know that as the pressure of the gas phase increases, absorption rates also increases, and it allows more gas molecule into contact with the liquid absorbent. And then the last one, we have nature of adsorbent and adsorbate, where polar adsorbent tend to absorb polar gases more effectively due to stronger intermolecular interaction.
There are several advantages for the absorption process, including its high efficiency at removing specific target components from a mixture, even at low concentration. Second, by applying the theory of absorption, we can selectively remove certain substances based on their solubility or affinity with the absorbent. Additionally, absorption is highly versatile, with applications in various industries, for example, the gas purification, chemical synthesis, and environmental management. Now let us moving on to the limitations of absorption process. First is the energy-intensive regeneration process required for recovery or disposal of adsorbent, which will increase the operational cost. Second, absorption process is not suitable for separating isotropic mixture, where the mixture will have the same composition in both liquid and the gas state at equilibrium. This will cause the separation process more difficult. Furthermore, absorption may less efficient in multi-component system, where the presence of multi-components can reduce the overall performance and the selectivity of the process.
Alright, so now I would like to explain to you what is the difference between adsorption and absorption by their definition. So AB adsorption refers to a process of one substance penetrates into the internal structure of another substance. A simple example would be water absorbing into a sponge. On the other hand, AD adsorption refers to a process of one substance sticks or adheres onto the surface of another substance. So a simple example would be water vapor absorbs onto a cold glass surface to form a thin layer of water. So now I want to do a simple demonstration for AB adsorption and also AD adsorption. So here I got some water. And a sponge. As you can see, when I put the sponge into the water will absorb into the sponge. Well, the water will be absorbing into the sponge, and this is the AB adsorptions. Also, I got to have some salt here. As you can see, this is salt. So when I put my finger onto the salt, the salt will stick onto the surface of my finger. So this is what we call AD adsorption. The object will stick or adhere onto the surface of another substance. So that's all for the demonstration. Thank you.
It's not just a specific concept, it's a process that enhances our everyday life in countless ways. Let's start with household. When a sponge absorbs water, it demonstrates absorption in action. Similarly, air purifier absorbs harmful gases, ensuring we breathe clean air. In industries, absorption plays a critical role. It's used to remove pollutants from emissions before they are released into the atmosphere, contributing to a cleaner environment. Additionally, ammonia is absorbed in water in refrigeration processes to maintain cooling efficiency. Absorption is also crucial in safety. For instance, charcoal in gas mask absorb toxic gases, providing clean air for breathing in hazardous situations. As we can see, absorption is a versatile process that enables clean environment, better healthcare, and efficient industry.
Absorption is a vital process in natural and industrial application, enabling efficient separation and purification. Key principles like mass transfer, solubility, and equipment design ensure its versatility and effectiveness in industry such as gas purification and environmental management, while challenges like energy-intensive regeneration exist, its high efficiency and practical application make it indispensable for advancing sustainability and productivity. Thank you. That's all from our group.